What's up, everybody? Hope your day is going well. Thanks for tuning in for 5.4, dealing with point-slope form. This is a new way that we can graph out equations, or at least a new way that equations can be written out. But you'll soon see that a lot of the stuff that's going on here is going to be very similar to what we've already seen and what we've already done. Slope, of course, is making another appearance. Definitely hanging out for quite a long time in this chapter. We see that slope's kind of nestled in the middle, but what are these other bits going on? I mean, we've seen y, we've seen x on its own. What's this new bit here? Well, x1 and y1 should look kind of familiar because if you can recall, when you were dealing with slope, you had that equation looking like this. And what x1 and y1 was just some point that was on the line. So really, that's just some point. It might be the y-intercept, but it might not be. Chances are it's not going to be. So what two things do you need based on the name? We need the slope. Or, I mean, in reality, we really only need 2 points because we can get the slope, but we need 2 points. So from 2 points, we can then go to slope. But really, we need a point, and then we can get the slope, and then we can nestle it into this type of equations in here. So as far as writing out these equations in point-slope form, we must know the slope. If we need to use the 2 points and find it, we can do that. Of course, using rise over run, or the change in y over the change in x. These come back again and again. You saw this first in 5.1, so if you need a refresher on that, go back and watch that video. When we use rise and run to get the slope, we need to know 1 point that's on the line. We'll label that as x1 and y1. We'll then plug in accordingly. So we'll see how this works. I know that I personally get stuck when I try to write these problems out, so I'm going to rewrite the general form. Y minus y1 equals the slope of m, parentheses, with x minus x1. Just so I have it on hand and I know what it means. So I know that my slope is good to go. So let's rewrite this with -2, parentheses, then x. So we kind of piece together these bits here in the middle. What should the x coordinate be? Like, we're always subtracting, which is a good rule of thumb. We're always subtracting the x coordinate. Which of these is the x coordinate? Should be saying +1. Got that right here. So we can denote 1 is x1. x1 went here. This is all equal to y, which is a steady variable. Please do not write a number in for this term here. And then we're subtracting the y coordinate, which is what number? Should be saying 5. So final simplified version, just reiterated, y minus 5 equals -2, parentheses, x minus 1. And we're done. We know that this is in point-slope form because we have y, we have x, we have terms in for y1, the slope, and x1. I'll give you a moment to try the next one. Taking this from left to right, we have y, we're deducting the y coordinate, which in this case is 2. This is equal to the slope of 1/2, with parentheses, with x as the variable, then deducting the x coordinate of the point, which is 4. So we got that. Oh, you need one more practice problem? That's fine. Try this next one out, where the point is now -2, -3, and a slope of 1/2. But be careful, because now what are your x and your y coordinates? So all right, same song and dance. Let's take y, let's deduct. But now what's the y coordinate that we're deducting? Should be saying -3. So I proceed with caution in problems like this where I put parentheses around that. We'll touch back on that in a moment. We then have 1/2. We have x. We're now subtracting our x coordinate, which is what number? You should be saying -2. All right, so let's simplify a little bit of this. Let's start first on the way left, because I said we were going to go back to that. If we're subtracting -3, how can we rewrite this? This little bit here, how can we rewrite that? Definitely, when we're subtracting a negative number, we can think of that as addition. So let's call it y plus 3. Let's keep that 1/2 locked and loaded. We'll have parentheses. We'll have x. Can we rewrite this? Subtracting -2. Now it. Rewrite it as +2. Circle it because you're proud of your work. Pause real quick. Make sure that these all look good to you before we go to the next bit. If you are stuck on these 3 problems, please take this time to rewind and make sure that they make sense before we continue. Maybe try the 3 problems out again on your own just to make sure that they make sense. We see in the next bit that we're starting to graph this out. So now we have the equation and now we're going to the graph. So let's break this apart by rewriting it. So I know it's always y1. It's being subtracted with the slope with parentheses x minus x1. So let's just keep that on hand. Well, I know that the slope is always outside the x party. We'll call this the x party, yeah, because this is where the x values are. We'll call this slope -4/5. And what about the point that's on the line? Well, I know that y plus 7 I could rewrite as y subtracting -7. And then I think it's pretty easy to spot that the point, at least the y coordinate, it's going to have to be -7. So the y coordinate here is -7. The x coordinate, this kind of looks as if it's just going from left to right, which is fine. X minus 4, so this is going to have to be +4 for that point on the line. All right, let's plot this out. So we can go 4 in the x direction, -7 in the y direction. That gets you here. Using rise over run, we see that our change in x is 5. I'm going to pick going to the left because I don't have too much room down here. So let's go over 5 units to the left. 1, 2, 3, 4, 5. So our change in x was -5. So if our change in x was -5, should we go up 4 units or down 4 units? Should be saying go up 4 units because you actually already used the negative sign. You already used that up. So let's go up 4. 1, 2, 3, 4. So our change in y was 4. We can keep this party going over 5 more. 1, 2, 3, 4, 5. Go up 4. 1, 2, 3, 4. Plot that out. I think we're pretty good with how many points we can fit on this, so let's use a straight line to graph it out. Show respect for all the points that couldn't make it onto the graph. Keep the arrows on there. When you're really crafty, you can also just say what points were on this. So the 3 points that we mapped out, because we were really awesome with this, were definitely 4, -7. We also saw -1, -3. We also saw -6, 1. I'll give you a moment for this next one. Try this out. So what's the point slope form of an equation going to look like for a horizontal line passing through 6, -2? And the hint is, what is the slope of a horizontal line? Meaning a line that looks like this. Just going from left to right. Not going anywhere. All right, well, let's sketch this out. That's always a good rule of thumb. Sketch out any problem that you think you can. So this is saying that there's the point 6, negative 2. So let's map that out. Going over once, twice, 3, 4, 5, 6, down, down. Horizontal lines go from left to right, so like this. It's pretty much saying graph this kind of line, where this point here is 6, negative 2. So if it's a horizontal line, we know that the slope's going to be 0. So recall that. We know that it's hitting this point. So let's even take this further. Let's have y subtract negative 2. The slope's 0. We'll soon see that's going to be a big deal. All right, cool. So the slope's 0, and that kind of makes sense. We put in x1 and y1, but look at this. This is x minus 6 multiplying with 0. Is that even noteworthy? Does this give you anything? So recall that anything multiplied with 0 is just 0. So really, you can think of this as y plus 2 equals 0. This is actually bonus points right here, because this is considered the point-slope form. But we'll soon see that if we were to take this further, the equation could also be interpreted as y equals negative 2 if you were going to slope-intercept form. So that last bit right here is kind of bonus points, but it totally makes sense. Really, in reality, the answer is right